At some point in the past, y'all would have looked at graphing. The basics of graphing here are basics of graphs. Here they are. So graphs look like this. The photocopier didn't do a great job of including the grid underneath, but there is one there. You can see kind of the dots there that should form the lines of the grid underneath these two arrowed lines. These two lines here, this vertical one, vertical goes up and down, and this horizontal one here, the one that goes left and right, are called axes. One of them is the x-axis, and the other one is the y. This horizontal line here, the one that goes left and right, we label the x-axis, and the vertical one we label the y-axis. So horizontal goes this way, the vertical is this one. And we have a name. Does anyone remember what this is called?
Coordinates?
We're going to talk about coordinates. It starts with this. It starts with a different C word. No. So close. Okay, so no, not actually. So like we've got the XY grid here. When we have a surface in math, so we've got this x-axis here, we've got this y-axis here, and we're going to review coordinates. Coordinates give us points on this grid. This is a big flat surface, and in math, big flat surfaces we call planes. So this is a plane, P-L-A-N-E. Yes, I did. There is a word that comes before plane that names this kind of plane.
Cargo?
It does start with C-A-R.
Coordinates?
No. We can play Hangman. You can get the rest of the letters.
Yeah, let's play Hangman.
Let's play some Hangman. No one has ever heard of what it's called before? Sometimes in middle school it'll get named for you. Nobody? Okay. Cartesian
I would have not.
is what this is called. Has anyone heard this word before?
No.
A few nodding heads. Okay. Named after a famous dead Frenchman. Oh, he's very famous. Just because you don't know him does not make him not famous. Do you know who Lewis Hamilton is? You know who Lewis Hamilton is?
I'm pretty sure.
Who's Lewis Hamilton?
Isn't he like the F1 driver?
I know a Hamilton.
You know a Hamilton. There's lots of Hamiltons. I was just picking someone who is very... So Hassan, yes, it's the F1 driver. The gray was just the F1 driver. Okay, Liam and Ethan and Danny. I don't know what's going on back there. I was just picking someone, Garrett, to give you an example of someone who's famous that you may never have heard of. Okay, so named after a famous dead French guy. His name is actually given to the plane. The Cartesian plane comes from this guy here, René Descartes. So this guy here, his last name is what we call this plane. And René Descartes was they call him a polymath. He did math, he did philosophy, he did physics. And there's one other science that's related to what he did and related to this idea of grid work that we use all the time. What is going on? Okay, so it comes from his name again. Does anyone know the science that... Does anyone take a guess at the science, an educated guess at the science that I'm talking about here? It does start with cart. It's related to graphing. Just stop, Ethan. Please and thanks. Maps. Yes. We call the cartography. This guy, René Descartes, pioneered the science of map making, which was a big deal back when he did it, because he was doing all this work at the birth of the exploration age, when Western Europe was like, let's go other places and invade other people and take land that doesn't belong to us, that belongs to someone else already. And they wanted to be able to document it so that they could go back to those lands and take more things. So map making became a big deal. So this is called the Cartesian plane, developed by this guy, Rene Descartes, who is also responsible for cartography, the science of map making. We've got the X and Y grid here, with the horizontal and vertical axes. Where the X and Y axis crosses over is this point right here. It has a name. Does anyone know what it's called? Middle. Yes, kind of. Center is getting closer. No, getting further away. It starts with an O.
Oh, hold on. Should I take $40?
No, you should just put your phone away. So this is the point right here where these two things cross. You can think of it as the center of the grid. And we start to number things based on this point right here. As we move to the right on this axis, we number it like a number line. We call this 1, 2, 3, 4, 5, or maybe you pick a different scale. Maybe you go by twos. On the y-axis here, as we go up, it's like a vertical number line. We go up. 1, 2, 3, 4, 5. So then as we go left, what would those numbers look like? Do you think?
-1, -2,
You.
-4, -5.
Okay. And as we go down,
-1, -2,
you betcha. So if they all grow out from this point here, then this point is the point what? On both of the number lines, what is the number of the, okay, what is going on?
I don't know, they keep taking my chair.
Liam?
I'm offering the grandpa.
No, put it away.
I don't want it.
Liam, okay, Liam, Hassan, Harsh, and Ethan. If the four of you, this is the second block back. Okay, I want you to take your desk. I want you to slide your desk all the way to the back wall. Just slide straight back until your chair doesn't go back any further, Liam. Liam, slide. No, all of you. We're gonna move all of you. You slide back. Give him his backpack back. Slide back. Hassan, I want you to come sit front row. We're moving all of you. It's gonna be great. Come sit right here. I didn't ask you. Just come sit. I don't care who took it. Come sit. Hassan's going there.
Why?
Nope. Just hold on. Hassan, I want you to sit right here.
I'm getting it.
Okay. Harsh. Right here.
It was Jared.
Right here.
Why did you tell what to stop?
And Jared, I want you to move over 2 seats.
Okay, get out of my seat.
There we go. Seriously, it's been an hour and a half. You've been back in school. Okay. That point right there, if you look at these number lines, what is that point right there? No, it's a number. 0. It's 0 in both directions, the x direction and in the y direction. So 0 is where these number lines start. They grow out from 0. So the name that we give for a starting point is, that starts with an O, is no. Where do things begin?
Wait, what are we at? What happened? I was writing stuff down.
I'm just wondering, like, what do we call where we begin? It starts with an O. Like superheroes always have a blank story that tells you how they became who they. Origin. Yes. So this is called the origin. It is where the number lines start from. They begin out of there. These are the points 0. And so it has a 0, it has a coordinate, 0, 0. This is where things begin. Now, if you recall, going back to middle school, that coordinates are always written how? Sorry? Yes. That is more complicated than we're going to get, but yes. Coordinates on a grid, which number comes first? Okay, I'll ask it a different way.
I'm trying to think of Minecraft, okay?
Is it the up and down, or is it the left and, yeah, think about Minecraft, that's great. Is it the left and right or the up and down? It's the left and right that gets labeled first. Yes, think of Minecraft. So that is called the x coordinate, the left and rightness goes first. Then the up and downness. But in Minecraft, you're doing 3 dimensions. So in Minecraft, you're actually doing X, Y, and Z. We're not going to do 3 dimensions because 3 dimensions is a lot more complicated than we want to go to. So we're just going to do X and Y. So the X value at the origin is 0 and the Y value is 0 there as well. Now, graphs have 4 regions. When you draw 2 lines like this, it splits up the graph into 4 spots. We call those spots quadrants. A quadrant. Do I have any Star Trek-y people here in the room? Anyone like Star Trek? No? Okay, never mind. Star Trek?
I watch
But you've never watched it yourself?
No.
Okay. Okay, fair enough. But not you. So quadrants, and these quadrants get labeled. Quadrant 1 starts in the top right corner. So this guy up here is quadrant 1. And in quadrant 1, that's this zone up here, if you take a look at how the number lines are drawn, X is positive as you move to the right, Y is positive as you move up. So in this whole zone here, X is positive and Y is positive. Because if you recall, these things get labeled X, comma, Y. And we label them counterclockwise because why not just make this super confusing? So quadrant 1 is the top right, quadrant 2 is top left. Over here, X is negative. These are all negative values here. The Y is still positive. So in this whole zone, you're going to have X's that are negative, Y's that are positive. If we keep going counterclockwise rather, this will be quadrant 3 down here. And now we've got negatives that are going down here. So X is negative and Y is negative. So both those numbers are going to be negative down there. Yes. Yes. That is actually a long-standing debate. Because I also, if you look at the map that we've got on the wall here, on the back above Miss S, there are huge problems with that map. Actually, that map is better than most. Because it's really hard to map a 3D surface, so a spherical surface, onto a 2D shape, you have to use what are called projections. And there are different kinds of projections depending on where you want to start your map. If you look at, so that is actually a really quite a good projection. Africa really is friggin' huge. There are other projections that make Africa look really small and the poles look really big. So like Greenland looks really big, Canada, Europe, Russia look really big. Africa is actually really crushed together. And some of those, one of those projections is called a Mercator projection. You don't need to know that. Just a fun fact. And it's actually very Eurocentric. It makes Europe look a lot bigger than it is. So the science of how you draw a map, a map of a spherical 3D object, our Earth, onto a grid, a 2D grid, is actually subject to a lot of, like there are some prejudices that are built into that. So having Africa be centric and huge is actually the best form of projection. So based on that, if that's the best, because Africa really is that big. And it's the one continent that often gets skewed in maps. Africa often gets made to look a lot smaller than it is. So having Africa and China look as big as they are is a really quite a good projection. So if you look at that one, Ethan, what quadrant would we be in? Quadrant 2, that's right. So I don't know what I was going to say there. I totally lost it.
Wait, are we using projections in this?
No.
Are they too hard?
The short answer is yes.
Like really complicated?
Surprisingly, yes.
But like the guy that made graph charts, where did he even find them? Like where you guys did you start there?
Yeah. That's why the zero time goes through a place called Greenwich, England. Like we define the lines of latitude and longitude, zero on that starts going straight through a town called Greenwich, England. My wife has been there. She went there a couple spring breaks ago for a wedding. And you can stand on it, and it is the line that separates what we call east and west. To the left of that line, you are now in what we would consider west. On the right of that line, you are east. And I mean, there is no really good place to start. It's no why are we saying, well, China is east of here, but China is also west of here. But we talk about the eastern part of the world to be like China. We have Southeast Asia is India, Thailand, China. But really, the quickest way to get to any of those places from where we are is to travel west. They're all west of us. So the guys who are the ones who put down map making to start were all based in Europe. And the quickest way to get anywhere in Europe, or the safest way, the first way was to take the Silk Road. And the Silk Road was east of Europe. And so that is why they call where they are zero. Everything to the left of them on that map, they called the west. And everything to the right of that, they called east. Because those were the guys that gave us a lot of the maps that we have today. Now, Chinese scientists and mathematicians were also doing their own versions of map making. They would have made China the center of their maps, and we would be to the west. We would be to the east of China, and Europe would be to the west of China. So it's where your projections start that you get to be the person that defines zero. And so because a lot of the graphing that we do is based on Rene Descartes' work, he gets to throw down zero where he wants to throw down. He says left is negative, right is positive, up is positive, down is negative. And there's actually some good mathematical reason for that. The physics is kind of complicated, and I'll just say it and move on, and we're not going to look at it in a lot of depth, but the universe is right-handed. So to call the right side of things to be positive, there's actually good mathematical reason for that. It's not arbitrary. And the universe is right-handed, which is weird to think about, but it is. So anyway, back to this. But good questions, all very good questions. Quadrant 1, 2, 3, so that makes this guy down here. Quadrant 4, I need a new color. Let's go lighter green, or kind of an olivey green. Is that guy there? And over here, my y's are still negative, but now my x's are positive again. So these guys are positive and those guys are negative. And so this is theoretically stuff that you should have been exposed to in middle school. Again, depends on who your middle school teacher is and if you were physically present in middle school or not. But graphs and things related to graphs. Flip the page when you're ready. Yeah, the calling zero on a map is really quite interesting. Because where do you call zero on a big sphere? You could call it where the birthplace of humanity was. That would be Iran, Iraq, somewhere in there. Yeah, it'd be it's an interesting political and racial discussion to have. Where is zero? Mesopotamia. There's a lot of ancient civilizations. What the first one was, we don't necessarily know, but we see it seems to suggest that ancient Iraq, ancient Iran, somewhere North Africa, somewhere in there is where humanity started. We don't know. It'll be a long time till we figure that out. So, going back to something Garrett said a couple minutes ago. Ordered pairs. We have another name for ordered pairs. We call these ordered pairs coordinates. Coordinates. It's an interesting word. It's kind of a weird word. Not very many words have that double O in there. Coordinates or ordered pairs have at least two numbers, sometimes more, that are separated by a comma inside the brackets. And they are always listed as X first, then Y. If you're playing Minecraft and you're actually working in multiple dimensions and you're actually working in 3 dimensions in Minecraft, this gets expanded to go to X, comma, Y, comma, Z. And this will give you a left, right, a forward, backward, and then Z is actually your up, downness. Y is forward and back, X is left and right when you're working in 3 dimensions. So that this X, Y grid, the plane that we're in, would actually be the surface of the Earth, and Z would be up into the sky or down into the ground. If you're playing Minecraft, for example. In this unit, we're going to be looking at linear relations. Linear relations are defined to be straight lines, and we're going to be looking at ordered pairs just involving X and Y. We're not going to bring in Z because drawing things in 3 dimensions on 2-dimensional surfaces is hard enough. So these ordered pairs show a relationship between these two variables, the X variable and the Y variable. So in other words, how something X is related to something Y. So things like how time travels, how time passes and distance traveled, or the amount of hours you work versus the amount of money that you're paid. These are all things that you can graph like this as well. So again, we're going to write this down so many times because students always forget. It always goes X, Y. The first number is the x-axis. It is the left and rightness of it all. The second number is the y-axis. It is the up and downness of it all. So if I have a grid looks like this, and I've got some points labeled on there, A, B, C, and D. You said A would be, were you labeling quadrants? Well, remember, where do the quadrants start getting labeled? Quadrants are always labeled starting in the top right and moving around counterclockwise. So this guy's quadrant 1, this guy's quadrant 2, quadrant 3 is going to be down here on the bottom, and quadrant 4 is going to be bottom right. So point A is actually where, Ethan? A is in 3. B is in 1, that's right. C is in, and D is in 2. And now we can actually go ahead and start labeling their coordinates or labeling their points in space. To do that, we always start at the origin. We figure out first how we move left and right, and then we figure out how we move up and down. So to get from the origin to point A, do we go left or right?
Yeah.
How far? You betcha. So that makes my x coordinate -4, because from the origin I went over 1, 2, 3, 4, and then on my y-axis we go down in A. -3, yeah. So then the location of point A is -4, -3. We went left 4, down 3. For point C, you are correct, Ethan. The y-coordinate is -7 for point C. Let's just jump to point C because that's where Ethan was going. What's the x-coordinate of point C? The 6. You betcha. So that would be the coordinate 6, -7. Remember, x always comes first, then y. Where is point B? 1 and 1. And then we can jump down and go back and look at point D. Where's point D? You betcha. The x goes first, -8, and then 8. Cool. When you're ready, flip the page. You're always ready. Okay, so I'm going to give you a smidgen of time. I would like you to take a look at page 3 and 4. On page 3, actually, I'll do question 1 first. We'll do 1 together. Because 1 is the other way. Remember, coordinates always go x then y. Yeah, those of you who play Minecraft aggressively are going to really benefit from that in this unit. So x then y. So let's label point I. If I is the point 7, -5, and x comes first then y, to label point I always start here at the origin at 0, 0. And we go left and right. If it's positive, we move to the right. If it's negative, we move to the left. And then we go up and down. Up is positive, down is negative. So I'm going to move. If the point is going to be at 7, -5, we're going to go 7 to the... No exponents in this unit. I want to graph the point 7, -5. So from the origin, I have to move 7 units which way? You betcha, to the right. 1, 2, 3, 4, 5, 6, 7. And then if I want to go to -5, I go up or down? Down. 1, 2, 3, 4, 5, down. I put a dot right there. That's going to be labeled point I. And what quadrant is I in? Not right now.
4.
It is, in fact, quadrant 4.
Wait, I'm on the wrong. Yep.
Should be on page 3.
No, I'm on the right page.
Okay.
I'm on the graph.
Oh,
I will watch it.
not right now. So I just asked Hassan just asked if you could go. So that's how we graph these things. I want you to do page 3 and 4. I'll give you, I don't know, 10, 15 minutes to do them. 10 minutes. 10 minutes to do pages 3 and 4. Hassan, you may use the washroom. When Hassan gets back, Ethan, you may go. When Ethan gets back, Harsh, you can go. Go fast.
Oh, okay, I see what
Okay?
I'm happy that
You're just putting points down
something actually makes sense.
on grids based on their location. Give it a shot. I want you all the letters. So I, J, K, L, and M, and then A, B, C, D, and E for question 2.
Time for J. Boom. That's oh. I did not do this.
You were supposed to.
Thank my middle school teacher. He actually works here.
He does? He works here now?
Yeah, right.
Who?
No, that's my English teacher. It's okay. Thank my
Who's your math teacher?
line Weber.
Oh, he's at Fraser now.
Yeah.
What are you doing? This guy for 7, -5. Down the line. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then -5 actually right on this.
Gotta make sure I was on the right track.
grid. 7, negative 5. So if I want 7, negative 6, we're going to go over to 7 and down to negative 6. Here. This is K. Try K. That is correct. Yes. That's it.
1, 4, 1, 4, 1. 1, 4, 1, 4.
Positive. Positive. And then negative number. Second number.
Are we all both? I got one more to do.
The reason I suggest winners. $5.
Perfect.
I mean, unless you want to punish them and get them golf pencils.
Well, that answers my next question. Because I was going to ask you, if I do go down and buy some, do you want me to get something for you as well?
No, I'm set.
You're set. Okay.
Sorry, what was that? German pencils or pencils? Yeah. Yes.
Is it up, down that goes first, or left and right?
Left and right goes first. Left and right is the first number. Up and down is the second.
So for B, that'd be 10.
Sorry, which one are you looking at? The letter B? This guy down here?
No, the other page.
Oh, we're on the second page. Did you finish that first page? Ouch. Okay, so if you're looking at the second one, B. Yeah, what about B?
Okay, so for the B is at like the top right area.
Yeah.
So would that go for the first number, that'd be 10 and then 6?
Left and right goes first and then up and down.
Okay, so it'd be 6 and then 10.
It'd be 6 and then 10, you betcha.
And then for A, that'd be 10 and negative 10 too.
You betcha.
Honestly, I was just guessing.
And then A would be in which quadrant?
2.
Yeah, and B is in quadrant?
1.
Perfect.
Can I go wash it?
As soon as Hassan gets back.
But I'm responsible. I think.
If you finish before he gets back, then you can go.
I've been done.
The whole page?
No. I've been done. No. Negative. And then C, that'd be negative 8, negative 3. I'm just pretending that was right now. Yeah.
Okay. You bet. I've got a few people going ahead of you. Ethan, you may go to the washroom. Okay. Okay.
It's on both sides.
Oh, that's great. We'll take them up in a second.
Park, are you done? No? You done any of them? Definitely not going back.
Remember, it goes the other way. So you go from 0, 1, 2, 3, and it goes, the number gets bigger, the farther out you get from the board. Alright?
Danny's done. Almost done with the washroom. Riley's done.
Okay. Let's take a look at some of these.
A whole bunch you guys have done.
Okay, if you are done, let's take a look. If you are not done, then we can do them together. So, put our phones away. We don't need to be on them right now. Let's finish graphing some of these points, or all these points rather. We did I. I is at 7, -5. And remember, X is the left and rightness. Right is positive, left is negative, and then Y is the second number is your up and down. Up is positive, down is negative. So for J, if we're going to be at 7, -6, starting from this point, the first number is +7. So that's an X, and it's moving to the right. And then -6 means we're going down 6. So that's actually going to take us 1 below where we were before. So that's going to be point J. And then that is going to be the same quadrant we were in before. That guy down here is quadrant 4, because it goes 1, 2, 3, 4. -7, -3. Let's graph K. So X is the first one. -7 means we're moving to the left. 1, 2, 3, 4, 5, 6, 7 to the left. And then -3 means we're going down to -3. That's that guy right there. And that's going to be quadrant number 3. So that's point letter K. L if it's going to be at 9, 3 from the origin, that's a positive number, so we go to the right all the way to 9. It's between 8 and 10, and then up 3 is that guy there. There's L, and then M is going to be this point right there. So L is in quadrant 1 and M is in quadrant 2. Comments, questions, concerns on any of those? First chunk of questions. Okay, then the bottom ones are going to look like this. A is going to be right here. Can we see the yellow? Yeah. Here's point A. B is going to be at 8, -9, so that's way down here. C is going to be at 9, -1, so that's that guy right there. That's point C. D is at 9, -3, so that's there. Harsh, you may go to the washroom. E, yeah, go ahead. E is going to be at 2, 4, which is right there. So A is in quadrant 4, B is in quadrant 4, C is in quadrant 4, D is in quadrant 4, and E is in quadrant 1. So that's 4, 4, 4, 4, 1. You good, Ethan? You had done that one already, I think. That's page 3. I'm just going over the stuff I've assigned.
How did you get 1, 4, 1?
That's what mine says.
Because we have both got 1, 4, 1, 4, 1, 4, 1.
Oh, remember these go like this: 1, 2, 3, 4. Did you get your points down here? Did you get some up here? Okay, remember it always goes X, Y. Is there any you want me to go over, Ethan, or you good? You chilling, you think? Denny, is Ethan chilling? Denny, are you chilling? Okay. So this is what it should, if you've got questions, please ask them. This is what question 2 should look like. I will happily go over any of them. We good? We're not hiding on our phone behind our backpack on this turn chair. Okay, here we go. And then this guy here, this one's the other one. I gave you the points, now I want you to tell me what the coordinates are. Remember, the coordinates always go X then Y. So A and B are done here already for us. Ethan asked about them, or actually Ethan did them for us. So there they are, A and B. -10, 2 in quadrant 2, and B is 6, 10 in quadrant 1. C is going to be -8, -3 in quadrant 3. It's right there. D is going to be what? You betcha. -8, -8. In quadrant 3 as well. E is right there. What are the coordinates of E?
1 and -1 and
E is 1 and -5. Good. And that is quadrant 4. F is that guy right there. So what's the coordinates of F? Yes, Dakota, I think that was your voice. 2 and -4 in quadrant number 4. G is this guy way the heck up here. What are the coordinates of G? You betcha, -7, 8 in quadrant number 2. H is 2, 5, and that's in quadrant number, sweet. I is, you betcha, 8, -2. You betcha. You betcha. You betcha. Love it. And then the last one was this guy down here. Find the coordinate of the following points without plotting on a graph. This comes from recognizing, so basically what it's asking you to do is, can you picture this stuff in your head to see where on the graph roughly it's going to be located? -2 means we're moving which way? Left. And 1 means we're 1 in the y means we're moving up. So if we went left and up, what quadrant are we in? 2. Left and down means we're in quadrant. You betcha. Right and up means we're in quadrant. +1 means we're 1 to the right. -6 means we're down. So if we're going right and down, what quadrant are we picturing? Quadrant 4, that's right. 8, 9 is going to be quadrant. And -5 is going to be quadrant. You betcha. Anyone want me to go over any of those in more detail? Comments, questions, concerns,
Can we watch a movie?
queries, conundrums, or constants? You missed movie day.
Yeah, it's because I didn't have to go to school on Friday, so I didn't.
You missed movie day. You did also. Yeah, a bunch of you missed movie day. Okay. Flip the page.
Wait, what did we watch?
We're going to start lesson 2. I don't remember what this class watched. What did we watch in this class? Was it the Teenage Mutant Ninja Turtles? Oh, it was a different class that watched Teenage Mutant Ninja Turtles. Yeah, we watched the newest Grinch. Yeah, there was like 3 or 4 versions of the Grinch. We watched the newest one. Okay, here we go. Linear relations. So we're going to we're going to take this drawing of points, and we're going to take it a step further. In this chapter, we're going to be working with linear relations. This means that we want our points to make straight lines. Even if the line isn't drawn. The question we're going to ask ourselves is, if I drew the line, would the line be straight?
No. Unless you have a ruler.
Touche.
Well, it depends on what it identifies.
So a linear relation describes the relationship between x and y. Things like time and distance, income and sales, battery percentage, and screen usage time. We have concepts here that one depends on the other. The more screen time you use, the lower the battery percentage is going to be. The more you sell, the more you make, the more time you move, the longer the distance is traveled. We can represent these relationships a bunch of different ways. We can use ordered pairs, which is what we've been doing, an equation, which we haven't done yet, but we will. Actually, we did it last chapter. Or a table of values, which is something you may be familiar with as well. A table of values looks like this. X is generally the left column, Y is generally the right column. But we can also use a grid. If I've graphed these things, does these points make a straight line? Does the line that is drawn look straight? Yes, it does.
Oh, no. Yeah.
So we say that this relationship here, whatever it is, we say that it's linear. Because I've got some points on the graph, and I'm able to connect them with a straight line. How about this guy here? That is also linear. How about this guy? It is linear because if I wanted to draw the line, I could, and the line would be straight. So those 3 are all linear. How about this guy? Can I draw one straight line through all of those points? Can I need to be able to draw one, just a singular line. Then no. So this guy here is nonlinear. How about this one? No. It's a line, but it's curved. So this is also nonlinear. And this last one? Could I draw a straight line through these 3? Even if there's no line, if I could draw a straight line through it, it's linear. The line does not have to be there for it to be considered linear. You just have to be able to do it if you're allowed. Okay, so we've looked at here. Are we cool with what makes linear and nonlinear? Yeah. Okay. So I want to bring in another concept here. We're going to look at something called continuous versus discrete. Continuous means you draw the line. Discrete means do not connect the dots. And whether or not something is discrete or continuous will depend on what kind of situation you've created. Hassan, are you on your phone hiding behind your... So for example, this guy here, because the line is drawn, what that means is if the line is there, I can have any fractional value and it's still considered valid data. The line means that any of the points on the line are allowed to be part of the problem. So if the line is there, we say that this is continuous. And an example of that would be as I travel, as more time passes, I've traveled a further distance. Am I allowed to have any fractional amount of time? Can I have like a half a second? Could I have a third of a second? Could I have a tenth of a second? I can have any decimal time I want. Could I have any decimal distance that I want? I could have 1 meter, I could have a centimeter, I could have a half a centimeter, I could have a tenth of a centimeter. So because of that, because I'm allowed any little bit of a fraction there, we can draw the line and we say it's continuous. This guy here, same reason, is also continuous. But this guy over here, it's just a bunch of dots that would be straight if I connected them. But because there's no line there, we say it's discrete. And an example of something that could do this would be like you go to a Bucket Slides pizza place and you're buying slices of pizza. Can you buy fractional slices of pizza? Can you go to Fresh Slice in the mall and say, I want half of that piece? No.
Unless they say yes.
But would they charge you for the whole piece or half the piece? Probably the whole piece. So if you're paying for the whole piece, you may as well take the whole piece.
But if you're not hungry, you just want half the piece.
Then they'll say, buy the whole piece and throw the other half away.
Fair enough.
Probably is what they'd say. There is no relationship on their menu board that says for whatever fraction of pizza you want, we're going to charge you this much. Easy way to do that would be pizza by the weight, which would be a weird way to sell pizza. But there are restaurants that do this. Often they're buffet style. Or like, there used to be like, you pick all your ingredients and they stir fry it for you and you pay by weight. But this isn't one of those. Or if you're counting the number of people, there's no such thing as a fractional person. You could have a short person, you could have an amputee. They still count as a whole person. So you wouldn't connect the dots. You couldn't say, well, I can have 1.5 people. It doesn't make sense. There's no such thing as a half a person.
No.
So this guy's nonlinear and discrete. This guy's nonlinear, but if the line is there, it's a continuous or discrete? Sorry? It is in fact continuous. And then this guy, I did add in the line afterwards. Without the line, it would be discrete. And now we're going to do one more thing, and then we're going to be done. And there's not going to have any homework. Let's take a look at this. So we can use graphs, already drawn graphs, to determine whether or not something is linear. Or we can look at a table of values. I could say, okay, look, I've got my table of values here. Here's X and Y, and I want to determine whether or not this thing is, whether or not it's linear or not. So what we're going to do is we're just going to treat each one of these. If I could get the drummers to stop drumming, please, I'd really appreciate it. And we're going to graph them all and see whether or not they make a straight line, and then we're done. So X is the first column, Y is the second column, and they go as you would expect, X and then Y. X is horizontal, Y is vertical. So this point here, -6, -4, is going to be in what quadrant? Yeah, you betcha. I'm going to go from the origin, I'm going to go left 6 and down to -4, and we're going to put that dot there. The next point is going to be -3, -1. So if I have -3, I'm going to go left 3 from the origin and down 1. It's going to be that guy right there. I'm treating each one of these rows in the table. What are you doing? See, now you're the only one there. I know it's you. Like coordinates. So then 0, 2 is going to be where? 0 in the X means I haven't left the origin. I haven't gone left or right at all. And now I'm going to go up to right there. I shouldn't have held my pen on the paper so aggressively. That point shouldn't be there. That's the origin. 3, 5 means I'm going to go 3 to the left or right, up or down? Right. And then 5, you betcha. So 1, 2, 3, 1, 2, 3, 4, 5. And then the last one, 6, 8 means I'm going to go 6 to the right and 8 up. Is that linear? Could I draw a straight line through these points if I wanted to? Yes. So we would say that yes, the relation is linear, and we would say we could draw a straight line. And at this point, we are done. We will continue with looking at tables tomorrow. You didn't even go to the washroom. We're done. Pack up. We will continue tomorrow.
I finished that page like 20 minutes ago, and I did the other one wrong.
Nice.
That one.
Don't go too far because there's stuff I want to do on that page.
Well, I only, on that other page,
This one?
I only did this.
Okay.
These
But I want you, did you graph them? See, I don't want you. I want you without.
Huh?
We'll take a look. I want you without the
did
graph.
I physically graph them? Or
Yeah.
You mean freaking
Oh, you just did them in your head.
Yeah.
Okay, we will take a look at them tomorrow. There's stuff I want to do in there. See you later, Miss
I
S.
play a lot of Minecraft. This is pretty simple.
Perfect.
Like,
Those of you who play a lot of Minecraft will be pretty good at this stuff.
2,000 hours, kind of.
That's a lot of hours. 2,000 hours? No, that's less than 10 days. Sorry, less than 100 days. That's like 83 days.
Yeah.
Wow.
In like 2 years. 3 years.
That's a lot of time spent playing Minecraft.
1,000 hours is just on one server. Like you can do /play time and see.
Yeah, I know, I've done that in games too. That's a lot of time.
1,044 hours or something.
That's impressive.
It's impressive, but not when you think about it. It's kind of sad to play that much. I mean, it's fun though.
Yeah, it's not ideal, but you know, that's what brings you joy and helps you de-stress. Okay, guys, you're staying in here. Where are you going? Ethan, get back here. Ethan, get back in here. Denny, where are you? Fantastic. Belle has not gone yet. Stay in the classroom.
I have such dry hands.
Cool. What else is going on here? Yeah, that's that.
That's just the polynomials test.
Yeah. Yeah, no.
Do you have anything else? Like my hand's not dry. But,
Only stuff that I use for my hands. Sorry.
yeah, I don't know why they're skin.
Guys, get back in here. Ethan, where are you? Hassan, get back in here. Do not go to Mr. Keeley's class.
I wouldn't say 50,000 hours, but like maybe 1,500.
It's a lot of
That's
time.
also just playing with friends and
Yeah.
stuff over. It's not just me playing by myself.
Okay, to email. Jenny. Katie. Kristen. Sorry?
It's okay. Like when you're on the linear, and then it gets a little more complicated.
It does get a little bit more complicated.
It's not like polynomials.
It's true. It's very different.
It's actually not. Like, I don't know. I can get used to it.
Jerry.
Do you know what my current grade is without polynomials?
You can look that up.
I am a bit nervous about it.
It is. If I omit this, 46, which is technically a pass.
Okay.
45 is a
If I do
pass.
the polynomials, then I should be fine.
Yeah. If you do well on the polynomials test, you will be fine.
I missed 3 weeks of school, and then everything fell behind. So
Yep. And then they started pulling you. And
if they try to pull me out for this polynomials test, you let them know.
Mhm.
Do it on.
I will
this
let them know.
day, so I can.
You can tell them to come see me.
Yeah, so like, in case this was the last time they came. They can pull me out when they see something that's not getting done, even though I plan. Do you know when final exams are happening?
Yeah, I do. Your guys, I was just looking that up actually. Your guys' final exam will be on Wednesday, January 22nd. If you could push that circle in the middle again, that would be lovely. Yeah, thank you. Circle again. Why isn't it working? There you go. Perfect. Thank you.
No, why are you holding my strings, Jared?
Okay, guys, stop playing with the light switches. Put them back the way they were.
You're responsible.
Okay, Hassan, it's the circular button on the right and the top button on the left. Have a great day, guys. We'll see you tomorrow. Top button on the left. Oh, Dakota, can you fix my lights? Top button on the left switch and the circle button on the right switch. Thank you. It is. How was Mexico?
It was good. It was really chaotic and kind of awful.
Why was it chaotic and awful?
So we first got there and like there was no meat it was an all inclusive. There was no meat.
How was there no meat at an all-inclusive?
The first 4 days no meat. There was.
Where was the meat?
It was gone. I don't know. And then they didn't do mixed drinks.
What?
Like, for 3 days. It was so annoying.
What do you mean they did? Hold on. What do you mean they didn't do mixed drinks? How is there no meat and no mixed drinks at an all-inclusive?
I don't know. And so there was a wedding too, so we could use the beach for the first 3 days.
Well, that would suck.
Yeah. And then we were like, okay, you know, we're gonna make the best of this. Everyone here is me. Us who don't speak Spanish. That's fine.
Where in Mexico were you?
Nuevo Vallarta.
Okay.
And so we go on like a tour thing of Vallarta, and like they're so aggressive trying to sell us stuff.
Yep.
And then we they have like it was like a tequila tasting, and it was just me and my mom, and they had dogs there, and like the dogs were out for everyone to pet, and like they had treats for the dogs, and you know they were cute, they were beautiful, beautiful dogs.
Yeah.
And the dogs had fleas.
Yep.
So my legs were all chewed up from the fleas.
Nice.
And we didn't realize until after. And then my mom, so like, my mom was already drunk at that point because it was like a tequila tasting. There was like 12 shots of different kinds. And the meal was like the only meat we had had the entire trip. So it was like glorious, but it was not that good. It was $200 USD for my mom and I.
On the tour.
On the tour.
Right.
Like they said food was included on it.
Yeah.
So we paid for the tour plus that money for the meal.
That sucks.
That we were stranded in the middle of nowhere. Like it was 2 hours out. We couldn't get food anywhere else. They made us get food. It was so
That really sucks. That does sound like a terrible vacation.
Yeah.
That was not my experience of having done a all-inclusive when I was in high school.
Really?
Yeah.
Was it like I mean I met some nice people, so that was good.
No, there was meat at the resort. They did mixed drinks. We were allowed to use the beach.
Yeah. And then David got to the car crash.
What?
Yeah. The 4x4 with his friends flung out the window.
Oh, no
He was in the
seatbelts.
hospital for 3 days. And
Poor choice. Did I see him this morning? Yeah, he's here. Okay.
he's here.
So he's okay.
It was when I was like it was the beginning of my trip. So my mom.
And you guys are dating.
Yes. My mom was on the beach crying. At that point, the doctors I know he was like internally bleeding his spine. And so the doctors were like, I don't know if it's going to be contained, if it's going to like happen. So my mom's crying. She's like, you don't know.
He should have even told you.
His mom texted my mom.
Mom should have just kept it to themselves.
Yeah. But it was just like,
Sounds like a lot.
it was a lot.
He was came here yesterday.
Oh, you were here yesterday too?
Yeah.
I was here yesterday. I didn't see you. I came to do a bunch of photocopying. Yeah, it feels like you never left, eh? But I was here yesterday.
I don't know where Casey is. He's from
Maybe that's why she's not here. Okay. Come here, Apple TV. Oh, Kira. There's Casey.
Hi. Oh, David wants to. No.
My microwave? Go ahead.
I gave David. I was like, I'll take your croissant. Oh. How would I know? And so I was like, okay, I want your croissant. She gives me your croissant. I'll give you $10 for your croissant. It has freaking mustard on it. I hate mustard. He knows I hate mustard. He's scared. Oh. You forgot my cranberry meatball.
can't do this. Okay, never mind. Sign up. Close. Here we go. Refresh. There we go. Hello, Karen. How are you? It was good. It was good. Always too short. How's yours? I understand that.
They do that at like
Okay.
there's like this page, which guy is it? Oh, the guy from Young Sheldon. I know. The guy from Young Sheldon, like the older brother. Yeah. Oh, I don't. Was it not? I remember it being like I just sent it to Dave. we were at Good Life. I don't remember this. Yeah. Yeah. And I was like, I saw one of the things we were at Good Life, and then I was like, your mom was watch too. And I was like, look. You put that away. I don't remember that. I don't remember that. No. What? Yeah.
Yeah.
he's actually really nice. No, no. A while ago, I want to go right now. And then he like stopped for a while because he got to be too much. And then he said he had another one.
Hey.
And then we heard how much he I was in the hallway.
Oh. It does feel like that. Bonjour. Okay, hilarious. I watched a Bluey episode the other day. I love Bluey. Bluey is fantastic. Have you seen this? Now you got me speaking in French. You reminded me of the episode I watched with my daughter the other day. So Bingo rolls in there. They're Australian, which is why it's hilarious. Bluey's younger sister wants a particular snack for dessert. Bingo's mom says no. So Bluey's like, let's go, the heavy winking. Let's go play cafe. Bingo doesn't pick up on it. It's like, let's go play cafe. And like, yeah. So then the girls go leave, and then Chili and Bandit are sitting there, and Chili's like, you need to get on that. And I was like, yeah, I got it. And so he plays up, he's a French chef showing up at their cafe. And he throws, like, he speaks French the entire time. None of the phrases make sense with each other. They're all basically butchered the way I butcher French at home. It's fantastic. Cor hates it when I butcher French. She was French immersion, born in France. Like, hates it when I butcher. Born in France? Yeah. Yes, she was born in France.
You speak French too?
Nope. Not well. I speak like a half a dozen different languages very poorly. So French is up there among the ones that I try and butcher. And she's really ticked that I've started to teach Natasha how to say French things improperly.
Oh.
So Natasha was bouncing, Jamaple, Natasha! Jamaple! Like, Cora's like, what have you done? Jamaple. Like, Je m'appelle? Jamaple? There was another one. What was the other one that Natasha was doing the other day? Oh. Je m'excuse. And the beef that I've been taking with the French language lately is that normally, talking to someone, you are tu. But if you're important, you're vu. That pisses me off. Like, everyone's vu. So Cora's like, no, not everyone is vu. I'm like, yeah. Yes, everyone is vu. Everyone can be vu. So, to a vu? And she's like, that's not how this works. I'm like, yeah, that's how it should work.
Funny thing. We're downstairs for lunch. Talking to Mary.
Yes.
Cal is away today.
Oh, lovely.
No replacement for Joanne.
Nice.
No replacement for Cal. Nice. So who did they move over to the office? Barb.
Oh, dear Lord. Oh, merciful heavens.
I think it was just for today.
Bye, Carrie Ann. Wow, poor Barb.
I know. I'm just like, she's probably.
Additionally, the
secretary in the counseling center. What is the left-hand side?
She's mean to everyone. I went to elementary school and high school with her son. She was the scariest mom of all of our friends.
And my mom actually helped mentor her to be a secretary.
Oh yeah, your mom was our secretary too. Yep. Small. It was weird.
My mom is not that mean.
No, his mom is delightful. She was a ray of sunshine. She was the secretary at my elementary school. And she was delightful. Ray of sunshine and light.
Yeah, unlike the other one who was there, Mrs. Gamble.
I liked her though too. I liked them both. I like Mrs. Gamble.
She was a lot more rougher sometimes.
It's 100%.
100%.
January 13th. Oh, nice. You're the first person who's commented on it.
I noticed as soon as I walked in this morning, like, I kind of want to do it too, but now I'll just be copying. You got to be the first one. Am I okay to copy?
Do it up.
I would love to.
I don't have the market cornered on Ted Lasso and fan memorabilia. Do it up.
Just make sure you what a great, for what we do, in physics, is what a great metaphor. It's kind of the same stuff, right?
That's kind of why I threw it out. The whole math, I was going to throw it out of the math wing, like coming into here.
Yeah.
You just gotta.
I think so.
You just gotta. Do it up.
How do I get onto Brightspace? Like, which link is it? I can't search it up.
Wait, hold on.
Schools.onlinelearningbc.com.
Or
I think if you Google Abbey Schools picking one of those ones, usually it used to come up better.
Because now it just like shows up all the university ones.
You just Google Brightspace, it gives you like D2L. That's the that's like the Brightspace company.
Oh, okay.
We have our own like server.
Have you been in his class in September and you're just learning now?
No, I used to be able to get onto it, and I don't know how, and then I haven't been able
Okay.
to. I used to.
Once you get in, you gotta put your bookmarks. We don't
Okay.
yeah.
Various agents.
And I think I'm doing fine.
Oh, Keely, I meant to tell you. So I emailed the crew, the powers that be. I didn't even get a reply email. I got, you know how in the little corner you can do like a little emoticon? Yeah, I got a thumbs up. Jury duty selection, but I'm not going to be here Wednesday. Yeah. I got a thumbs up. Not like, I don't know. There's a part of me that's just like, I'm sorry. See you later.
See ya.
You're the principal in charge of the building.
Yep.
An email reply would be better.
Yep.
You gave me a thumbs up.
But in her defense, she probably hasn't checked her email in 2 weeks.
Oh, I just sent it.
But
Which probably got a lot of emails.
probably reading through a ton of emails over the last 2 weeks. But
I don't think I'm ever going to get.
But I still agree with you. That very simple. Okay, thanks. Let me know.
Yeah.
Now, part of me is even going further with that, and saying, okay, I hope you do get selected.
I'm torn.
I know it's a tough time of year.
I am torn. It would be an awful time of year to
It'll
go.
be brutal.
Yeah.
But it would be your problem.
It would not my problem. It's true. Okay, I put in my absence. I have been. So when the BC jury selection people, when they select you for a jury, yeah, you can't not go.
Why?
There are certain ways you can get exempt. I don't satisfy any of them.
What is jury duty?
It is once you are of legal voting age, it is your civic duty. Like, you have certain responsibilities as a citizen that should the government call on you, you have to do it unless they give you an exemption. One of them is jury duty.
What is it?
So when they have, in this case, the thing I was selected for, I have been called to jury duty selection, and they call, I don't know, 100 people randomly from this pool of eligible voters, and you have to go to selection, and depending on the case, the selection can be easy or can be a lot more involved. This is the second time I've been called for jury selection. The first time, they just picked the first 12 people, and they're like, does anyone have any objection to this guy? Nope. This guy? Nope. This guy? Nope. And I was number 10, so I got picked for jury duty, and they're like, they didn't care about any of us. Like, cool, you're our jury, you go into the room, and as soon as we got into the room, 10 minutes, they're like, we'll come back in a couple minutes, we'll tell you what's going to happen here. While we were gone, the defendant changed his plea to guilty, so I didn't actually get to serve on the jury. This time, it doesn't look like that's going to be the case. So on Wednesday, I will be away, because I am legally required to go to jury duty selection, unless I get sick but I didn't get an exemption. So if I get selected for that, it's a 4-week criminal trial. So I would be gone for the last 2 weeks of the semester. So, well, the final exam's ready. It's ready to go. So you would be reviewing for the last week of, which is my plan anyway. Your guys' review would start next week. The week after that, which is your exam week, I wouldn't be here for. And then the first 2 weeks of semester 2, I'd be gone for that as well. Which means someone else would have to write my report cards, which would be weird.
When did you still do that?
Sorry?
When's our exam?
I just looked that up. Let me look it up again.
Examination day.
Examination day is...
Next week, what?
Your exam is tomorrow.
Huh?
Just Raven. Just Raven. No. You guys are block C, Tuesday, January 21st.
Yeah, I don't know.
So not next week, but the week after. You guys have,
First block?
okay, I don't get to choose this. Okay, give me a couple seconds for everyone to roll in. I will tell you how the next couple weeks are going to go. All of this started because you're asking about jury duty. So what jury duty is you are, they try and bring in a jury of your peers,